Imagine you met this question in your exam. What will be your answer? Hello and welcome to Chemistry with Lisa. Today, here we simplify chemistry for you just to make you truly understand and boost your grades in chemistry. Today, we have an exciting topic to discuss on Boyle's law. At the end of this class, there are a set of questions for you to answer to assess your level of comprehension. So make sure you watch this video to the end. Now, let's dive into the class. So, Boyle's law states that at constant temperature, the volume of a given mass of a gas is inversely, take note, inversely proportional to its pressure. The temperature is constant. Once the temperature is constant, the volume of a given mass of a gas is inversely proportional to its pressure. Now let's express it mathematically. It means that the volume of a given mass of a gas is inversely proportional to its pressure. So this is how to express it mathematically. Inversely proportional to its pressure. So what does this mean? This means that V is equal to K over P, where K is constant proportionality. Then cross multiply. This will be K is equal to PV. So this is how we arrive at the formula that states P1 V1 is equal to P2 V2. Isn't that simple? So when we say inversely proportional, it means that as the volume is increasing, the pressure is decreasing. And as the pressure is increasing, the volume is decreasing because they are inversely proportional. Now, your examiner may ask you a question that has to do with Boyle's law. So take note that Boyle's law, the pressure is increasing as the volume is decreasing. Volume is increasing as the pressure is decreasing. So let's look at some questions. The volume of a gas at 99 Pascal is 300 milliliter. If the pressure increases to 188 Pascal, what is the final volume? Now, I want us to be able to identify our parameters. So, pressure, everything pressure is represented. What are the units of pressure? The units of pressure include ATM, that is atmosphere. It also includes millimeter mercury. It also includes Newton per meter square. They can write it like this or they will write it like this, Newton per meter square. And it also includes Pascal. 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 Then how do you identify volume? Volume is identified by dm cube, cm cube, meter cube, liter, or milliliter. How do you identify temperature? Temperature is identified by temperature, degree Celsius, degree Fahrenheit, or Kelvin. So please, I want you to note these parameters here. They are very important. So that when you see ATM, you know they're talking about pressure. When you see milliliter, you know they're talking about volume. When you see degree Celsius, you know that temperature is being mentioned. Because sometimes the examiner may not call the name, they will simply give you the parameter, expecting that you should know that this is temperature, pressure, or volume. So let's solve this question now. Okay, so let's solve this question. The first thing to do is to write out our parameters. What are the parameters here? We have 99 Pascal. So what is Pascal? Pascal is what? Pressure. So pressure is 99 Pascal. And what is milliliter? Milliliter is volume. That is 300 milliliter. If the pressure increases to 188 Pascal, 188 Pascal, what is the final volume? So the first pressure is P1, the first volume V1. The second pressure is P2, the second actually looking for V2. So using Boyle's law, now if you look at this question, there was no mention of anything temperature. And even if they mentioned temperature, the parameters given to you determines what you would solve. So that is why it is important you always list out your parameters while solving. So what would this be? P1 V1 is equals to P2 V2. So P1 is what? 99 times V1 is 300 is equal to P2 is 188 times V2. So let's punch our calculator. That will be 99 times 300. That will give us 29700 is equal to 188 V2. Divide both sides by 188. What do we have? Divided by 188, we have 157.978 equals V2. So approximately to the nearest whole number, that will be 158, because this is up to 5. You call it 1, add it to this person, it will be 158 milliliter. Please make sure you leave your answer in the volume that it was given, which was milliliter. Isn't that simple? Let's look at this question. What will be the new volume? New volume we are looking for if the new pressure is halved and the initial pressure remain the same. So let's write out our parameters. It will be what? New volume is, we don't know. So let's write out our parameters. Initial pressure, P1, there was no value. Then V1, there was no value. Then the new volume, V2, is what we are looking for. If the new pressure is halved, P2 is halved. So look at the options given. P1, A, B, C, D. These are the options given. So let's solve. So you have that P1, V1 is equal to P2, V2. P1, V1 is equal to P2 is what? Halved. So this will be 1 times P2, P2 all over 2, V2. So let's look at the options given to us. The option given to us, P1, V1, no. P1, V1 over 2, no. P1, V1 over is equal to P2 over 2. Good. This is the correct option. This is the answer to the question. So this question is for you. A given quantity of gas occupies a volume of 280 cm3 at a pressure of 750 millimeter mercury. What is the volume at atmospheric pressure? Now, some of you may be wondering, what is atmospheric pressure? Atmospheric pressure is 760 millimeter mercury, and it is the same as standard pressure. It is the same as standard pressure. So atmospheric pressure is standard pressure, which is 760 millimeter mercury. Then you also have your standard temperature as 273 Kelvin, and standard volume or molar volume as 22.4 dm3. Please, you must note these values, because as we progress in gas laws, you will definitely need them. All right, kindly drop your answer in the comment section. Thank you for watching. Please do well to subscribe to our channel to help us do better for you. Thank you. Bye.